Everybody, in this lesson we're going to talk about atomic mass and Avogadro's hypothesis. What atomic mass is that it's related to Avogadro's hypothesis and determines the mass of each element. Now if you want to check out a funny video from Austin Powers, there's one about what a mole is. We're going to introduce what a mole is in this class. So what is Avogadro's hypothesis? Well, it came from, so first of all, Avogadro himself was a scientist, but it came from Dalton, in which Dalton believed that molecules were made up of atoms. Okay, so not only did they believe that they were made up of atoms, they combined in specific ratios. So what does that mean? Well, for example, what he found was 2 grams of hydrogen gas can only combine with 159.8 grams of bromine gas, or in this case, bromine liquid, really. He found that that was the ratio that it formed. You couldn't combine, for example, 1 gram with 159.8 grams of bromine gas. So they had to combine proportionally. Because of that, he found that if you were to find the ratio, he found the ratio of hydrogen to bromine was 1 to 79.9. And if you look at the periodic table, you would be able to find that, in this case, bromine has what we call atomic mass of 79.9. Hydrogen has atomic mass of 1. So what you can conclude then is that bromine is 79.9 grams, or 79.9 times heavier than hydrogen. Now what Avogadro's hypothesis is, and this is what Dalton built upon, is that Avogadro's hypothesis talked about this. It states that equal volumes of different gases at the same temp and pressure contains the same number of particles. Okay, so that's what he's saying, is that if you have equal volumes of different gases at the same temperature and pressure, they contain the same number of particles. And this Avogadro's name is going to come back again in this unit. But let's look at this example here. If 500 milliliters of nitrogen gas combines with 1,000 milliliters of oxygen gas, how many oxygen molecules are present for every nitrogen molecule? Well, based on Avogadro's hypothesis, if equal volumes contain the same number of particles, then what happens if you have twice the amount of volume of oxygen gas? Well, in this case, because there's twice or 2 times oxygen, what that means is you will have 2 times the O2 molecules versus N2 molecules. So what does this have to do with a mole? Because a mole is something on your face, or a animal on the ground, or it's a spy. But a mole in science, in chemistry, is a bit different. It is defined as the number of carbon atoms in exactly 12 grams of carbon. So how many carbon atoms are there if you had 12 grams of it? And it's a very large number. But instead, what we define it as, really, it is defined as the amount of substance. And we talk about substance, we talk about, for example, atoms, molecules, or just particles. So it's a new unit we're going to use. And it's going to be the basis of our mathematics in Chemistry 11. We're going to use this moles a lot to help us calculate because it allows us to relate between masses, particles, and volumes. And it comes from Avogadro's hypothesis. We're going to finish up this lesson with talking about what atomic masses are. Atomic masses are masses of each atom. But due to how tiny an atom is, its mass cannot be measured. So what do? We use the mole to explain. So what we do instead is we find a mole of an element and find its total mass. And once we know its total mass, we can divide it to find the mass of one atom. And we did that with carbon. We found that carbon, if we had 1 mole of it, would have a mass of 12. And thus, because of that, if we had a mole of nitrogen, it will have a mass of 14. A mole of oxygen will have a mass of 16. So this is where all these different masses come from. It came from the fact that it's basically the ratio to carbon. It is the ratio to the mass of carbon. Now, in our next lesson, we're going to talk about finding molar mass, which is what happens if you have to find, for example, the mass of CO2. But as always, make sure you keep yourself safe and healthy, and I'll see you soon.